Okay, welcome everybody. We have three great presentations for you this afternoon. We're going to start with David Adsit from Pluralsight. Since David was first introduced to Apple II Basic in the fourth grade, he enjoyed programming, but when he was introduced to TDD, his passion for code really ignited. Since then, he has worked to help build teams that build well-tested software. Though many developers prefer to work on greenfield projects, David enjoys helping a team rescue a ball of mud. And so David is going to talk to us about architectural refactoring, so please welcome David.
Thanks. I'm Mike, so we should be good. Okay, so I'm going to talk about architectural refactoring, and this is going to build on some of the talks you may have already heard about today. Here's all the things about me that he just said, and maybe a few more. And what I'm going to do today is I'm going to share a story. This is an experience report, so I'm going to tell you the mostly true story of architectural evolution and refactoring at Pluralsight over the last 4 years. I started there 4 years ago. Oh, first let's start with a brief definition. We all know what software architecture is, right? Borrowed this from Martin Fowler. It's the stuff that's hard to change. Apparently, I could have also borrowed it from Grady this morning, but I happened to have Martin's picture in my slide already. And what is refactoring? Many of you should know about this already if you work with software. It's changing the structure of code without changing the behavior. So the question then becomes, what is architectural refactoring? It's changing a system structure without altering its features. And one would ask, why would we want to do that? But first, I have a better question. What is this right here? Does anybody know?
Rock in a hard place.
It may be. It may be. It's actually a bridge for livestock. You probably couldn't tell from the way it was structured, but that rock is, in fact, a system that allows sheep to cross from one side of that cliff to the other. Okay, so why would anybody want to do architectural refactoring, right? There's a couple of reasons, and quick. There we go. So one is when our technology fails to meet the needs of our users. I mean, those guys are all getting to their destination. Maybe not in style, but they're getting there, right? Another reason that we might want to change or do an architectural refactoring is when our team fails to meet the needs of our organization. So those are our two big reasons, and they're kind of orthogonal to each other, right? Our technology isn't failing, or isn't meeting our needs, or our teams aren't meeting the needs of the company, right? So let's talk about architectural drivers. You guys know all of these inside and out by heart. I don't even need to go over them like I would if I were talking to software developers instead of architects. And of course, you're well familiar with all of our constraints as well, right? I mean, when I started at Pluralsight, it was kind of startup land, and so money wasn't a constraint, right? No, that's not true, right? So we always have constraints, and we always have architectural drivers. And what I'm going to talk about for the remainder of this talk is patterns that we can use for change, right? I don't even know where I found this slide. I would say my wife sews, but she doesn't. She thinks that's boring. So a pattern is a generally reusable solution for a commonly occurring problem within a given context. The key here is context. The things that I'm going to talk about applied to the context I was in with my team at the time we made them, and they may or may not work for you in the context you currently face. If they do, great. If they don't sweat it. You have a different context. You need different patterns. So when I started at Pluralsight 4 years ago, we had a team of 4 developers. I was the 4th, actually. And the first thing we did is we built a monolith. Right? I mean, in the era of microservices, monolith is kind of a bad word, but we built a monolith. And why did we do that? Let's find out. It was fast and easy. We had 4 developers working on one shared code base, one Git repository. Actually, at that point, it was SVN, but it was Git pretty soon after, right? You can do it with a small team, which is good because that's all we had was a small team. and you could change things really quickly, right? So we were going through really quick iterations. We were releasing our code to our users really quickly. We didn't have need for a QA handoff, which is good because we didn't have any QA to hand it off to. We did our own testing, and then we put it in production, and then we got emails from users. We didn't have any need for an ops handoff, which is good because we didn't have any dedicated ops. We also, the 4 of us were running that server ourselves. And yes, I did say server. We'll talk about that in a minute. So one of the very first refactorings that we did, let's see, I should tell you, we were running our entire production application on one server. The database was on that server. Actually, 2 databases were on that server. And the web application were all running there together in production on one box, one instance. It was a physical box that we had hosted. So one of the very first things that we did is we decided we had to leverage a CDN. When we started getting a certain amount of requests to that server, it started to choke. It couldn't handle the load. So we start offloading a bunch of stuff to the CDN. You know, we're using the internet to cache our data for us, right? Click. Maybe I need a new battery for the clicker. There's a space bar, right? There we go. So we were able to offload a bunch of traffic from our web server to a paid subscription service, the content delivery network. And as a secondary benefit, that allowed us to do better response times for our users that didn't happen to live geographically close to our Salt Lake City data center where we hosted our one instance. It turns out that, like Grady was talking about earlier, physics comes into play. The speed of light is a real factor when you have customers in India and you only have one server in Salt Lake City. Okay? So the next thing we did as soon as we got that CDN implemented is we decided we had to improve our infrastructure in order to meet our load. We clustered our web servers and we pulled that database off of them. So we now had a small collection of data of servers, right? We actually put, we moved our web application to virtual servers hosted in the same company, and we kept that physical box as our database because we weren't super sure about this cloud deployment of databases 4 years ago. Let's see if I can get my slides to advance. There we go. Okay. Yeah, those things. And then when we noticed that one of the things we needed to do was eliminate session state. I don't know how many of you guys are using pinned sessions where you've got a load balancer and it's distributing load across all your web servers. And this is great until you realize that you have to pin users and you might end up with spikes on one server or another. So we eliminated that session state and we started relying exclusively on the database server to manage session and to serve the user state directly to the users. We'd load their state and serve it to them directly without having session in the web servers. And then this was something you may have heard about earlier today as well in one of the other presentations, is replacing feature branches with feature toggles. We found that our team was starting to work on different things at the same time, and integration points were starting to become difficult because they would start to expand. The time between when I start working on something and commit that feature branch back to master or back to trunk, something may have changed, and now I have to spend additional time merging and resolving conflicts, and maybe I'm in a hurry and maybe I screw something up, right? So we went to a strategy of feature toggles, which allowed us to push those features to the master branch constantly, right? And then, you know, it improved our continuous integration. We were constantly integrating with each other's code so that we didn't have any drift. And then also, this allowed us to decouple our deploys from our releases. So you could deploy code dark into production, and no one would see it until you flipped the switch and it came on, which was great, especially when you flipped it on and it didn't work, and you needed to flip it back off. You didn't have to roll back. You could just do a config change and turn the feature off, right? So that was an advantage to our team in being able to move quickly and safely. It allowed us to mitigate some of the risk of rapidly deploying our code to production because we were able to turn features off and on quickly. So this led us to explore some additional optimizations on the website. We're starting to grow traffic, right? I don't know if I mentioned, when I started 4 years ago, we had less than 40,000 total subscribers on our system. Less than 10,000 of them were active, and you can manage that load pretty easily. Today, we have over 1 million registered users and over 300,000 that are active. Our daily active users is somewhere in excess of 50,000 users, right? So we're scaling up that load. And we decided we needed to start separating apart the user-specific data and the system-specific data and the other static assets, right? That allowed us to implement a more aggressive caching strategy. I can cache some of my content for a week at a time, but I might not cache user-specific data at all. Or I can cache those static assets for significantly longer. Hopefully we don't change our logo too often. It's kind of a joke. We've changed it 4 times since I started 4 years ago. But that also allowed us to leverage our customers' hardware to do processing for the website. You guys are probably all familiar with these concepts if you've worked long in web development, right? The next thing we realized is that our primary database, our OLTP database, was a document database, and we were starting to reach the limits of how many requests it could handle in a given period, right? So we had to go through a process of splitting that database. We sharded it. We didn't do, the database that we chose early allowed us to move quickly because document databases are schema lists and they evolve quickly, and the data was stored in JSON, so it's easy to work with, right? But it didn't have a native sharding mechanism. So we took that database and we manually sharded different collections of data onto different servers so that we could split the load based on what was causing us to hit those write limits. And the read limits were fine. The write limits is where you kind of run into trouble with the document database. Right, so let's see. There we go. The next thing we did is I mentioned earlier that we had a document database for OLTP. At some point, we had to introduce a SQL database for ad hoc reporting. I don't know how many of you have actually worked with the document databases. They do not do well at roll-ups and aggregation. That's not their purpose. They're really fast at reads and writes, but they're not great for joins if they support them at all. So we added another data store. And then, oh, good, thank you. And then we added additional miscellaneous databases to support other needs. We explored briefly a graph database. We have an online catalog of a bunch of courses which have authors that may have authored other courses, right? So we were like, what if we used a graph database to detect the number of common tags or themes or whatever between courses and let people find related content that way? And we tried that for a while and then took it down. But we also introduced a key value store. We use Redis, and it's a very fast cache type database to store keys and values, right? We also started to experiment with Cassandra. So now we have a Cassandra ring inside of our production system where we can use that database. And people sometimes call it a columnar database. I just call it a Cassandra type database because there's only the one, right? Nobody else has implemented a database quite like it. So by doing a polyglot data store, we were able to use special purpose tools for the needs that we had as a business and as a team. I don't know. I give up on the clicker. There we go. And this was a fun one for me, because this has been a pet peeve for a long time. We replaced the queuing tool that we had written in the database with an actual queuing tool. We chose Rabbit, but it doesn't matter. What matters is that, who here has done that, by the way? Who's implemented a queue of some kind in either SQL or a document database or flat files? Like literally every company I've ever worked at, somebody had made one of those, right? Because you already have SQL Server in your infrastructure, and it's easier to build a series of super complicated stored procedures than it is to finally get the ops guys to install something super simple to manage like Rabbit. So don't do that. I mean, again, I've done it for you. Rely on my experience. I have built a queue in just about every database I've ever used, and it's not ideal. It doesn't give you the kinds of guarantees that a true queuing mechanism like Rabbit or Zero or ActiveMQ will do, right? You want at least once guaranteed delivery of your messages. Of course, during this process, we were hiring developers. All the things I described there, 4 people aren't going to be able to do in any kind of reasonable time frame. So we were aggressively hiring to build up our team so that we could deliver more features to the user. Remember I told you earlier the architectural refactoring is when your team, one of the reasons to do that is when your team cannot deliver on the needs of the business anymore, right? So our team got big, and that made it hard to manage, and we started having to add a bunch of overhead to how we were working together. You know, it's 4 people sitting in a room. You're like, hey, I'm going to do this. Okay, do that. Hey, you should do this. Cool, let's do it. When you start to have multiple people, or a larger team, and they start to get distributed, and they come into the office at different times, you have to start introducing ceremony around how you work. So we split our team. And I think it's mandatory that everybody mention Conway's Law during SATURN this year. I think that was the memo I got. So we decided to leverage Conway's Law. Instead of splitting our team into the front-end developers and the back-end developers, the way the front-end developers really wanted, because they all were super excited about working only in JavaScript, right? We were like, let's split the other way. Let's do cross-functional teams with a product manager, a UX specialist, some developers, and an ops person. And together, you guys will take ownership of a piece of the system, and you will be responsible for delivering and running it, okay? So we did that repeatedly to the point where now we have about, hard to count, maybe 12 teams. From our original 1 team of 4 people, we ended up with about 12 teams. Of course, we also had the privilege of being a startup with some money. So that meant we were buying other startups who had run out of money. And that means we got to inherit their technology stacks as well as their developers who were expert at running those stacks. So we went from a single stack, which was AngularJS on the front end, .NET on Windows for the application servers, and RavenDB in the back end, right, with our polyglot data store. We suddenly found ourselves with .NET and Python and PHP and Ruby. And so as an architectures team, we sat down to talk about the constraints on the system is that we have to integrate all these pieces, and we came up with some ideas around how we would do that, okay? And so we rolled those ideas out to the system. We created a system that would support all of the mandatory technology stacks. And of course, if you build it, they will come. So almost immediately somebody said, I want to do Node.js. We're like, well, there's no technical reason why you can't add Node.js to our stacks. And somebody else said, well, we want to do Scala because we're really into functional programming. So now we have .NET, JVM, Node.js, Python, PHP, and Ruby. And in about the last 2 weeks, I've heard developers start talking about how Node.js is so 2015, we should be looking at Go, right? So we'll talk about that a little bit more at the end. Another thing that we did is we migrated from our hosted data center into the Amazon cloud and then started splitting our infrastructure across multiple zones with the intention to move into multiple regions for redundancy, disaster recovery, et cetera. Reduce that risk against our contracts with our customers. Let's see. There we go. And of course, that also reduces the response time for those people who are unfortunate enough to still live far away from our data centers. The speed of light, despite recent legislation, has not been raised. Just kidding. Okay, so here's one of the patterns that we applied multiple times. Extract bounded context. You can see on the left we've got our monolith. It's got some websites, it's got some servers, some services, database, and we transition to the right where we've extracted something from that. It's a collection of microservices, micro websites, a shared data store, and an anti-corruption layer that becomes an atomic unit in our system, right? We refer to it as a bounded context, again, borrowing from domain-driven design. It's a collection of things working together that serve a purpose to our business. We'll have a product team work on that bounded context. And we separate it out so it's not using a shared database, it's using some very specific communication mechanisms back and forth. And so the pattern that we're currently working on right now is Strangle the monolith. We are repeatedly extracting bounded contexts from our monolithic code base with the intention that we will reach a point where, like this strangler tree, we have killed the original host and moved all of the value out of our monolith and into a collection of smaller bounded contexts. Of course, this leads us to have, if everybody owns their own database and nobody else can access your database, but they need to know stuff about your data, we had to have a distributed system of record. One bounded context becomes the system of record for a type of data or a piece of data. And that might be a subset. Like you think if you're doing your data modeling, we have a user, and the user has all this stuff attached to them. Well, in our system, you have a user, but that user is an aggregate of the user data that belongs to this bounded context and the user data that belongs to this bounded context. Two examples being, we have an identity team, and the identity team works on the identity of the user. That includes their profile and their email addresses and their password and stuff like that, and their bio. And then we have, on the other side, the subscription. And the subscription is actually owned by a different team, and they just tie that together with the user ID. And then we will actually let different bounded contexts take local caches of that data so they can make quick decisions, but they're read-only. You know, you get a copy of my data, you put it in your data store, and you query against it to make decisions locally, but you can't write back to my data store. Okay? So, to do that, we're using an asynchronous communication pattern. We chose to do fan out, publish, and subscribe. When something interesting happens within your bounded context, you publish a message with information about it, and anyone in the system, any other bounded context can subscribe and write that data locally for their own use. And of course, as I mentioned earlier, we're using RabbitMQ to guarantee delivery. Okay? And that obviously doesn't work for every scenario. You have some things that are very stateful and algorithmic, for example, search. It is completely unreasonable to pre-calculate every possible search a user could put in and distribute the results to everyone, right? You need to have a request-response type of pattern. And so for that, we do use HTTP. We use JSON over HTTP. And we try to be RESTful, figure out what that means on your own. And we use that same JSON-based data packet that we do in the messages that I talked about. So all of our communication between bounded contexts occurs in one of two ways. You either publish a message onto RabbitMQ into a fan-out exchange that is in a JSON format that any one of our 6, possibly 7 tech stacks can deserialize, or you provide an API that has endpoints that serve JSON data. And often they serve the same type of data. So let's quickly jump through there. You can read up on circuit breakers later, I think. Maybe. Okay, so let's talk a little bit about orchestration and choreography. Basically, there's 2 patterns for organizing a distributed system, right? One, you can have a central conductor that runs the process, and the other, you can create a choreography, such as a ballet, where every dancer is doing their own thing, And together, they create something larger than each individual piece. And we are using a combination of both, depending on the case. Typically, we are choreographing our different bounded contexts to create a system that serves the user's needs. But sometimes you need something monitoring the process to make sure nothing goes awry, and in that case, your orchestration is going to be the key to solving that, okay? So what we chose to do as an architecture team and as a development team is trade total complexity for local simplicity. This is from the, I don't have my speaker notes, but it's the something economic complexity across the world anyway. So if I'm working on the team that does the stuff on green over there on the right, I don't have to worry about what's going on over here in purple land, right? So my local complexity got smaller, even though the system as a whole is now more complex because of some of these patterns we chose to implement. So how long does this take? Forever. It's a constant process. Always address your highest point of your highest problem, right? Whatever is giving you the most grief right now, that's the thing you need to address, refactor around it so that you can move your system forward. And I think I have a couple of minutes for questions, if anybody has any.
Can you talk about how you established your bounded context at the beginning when you went from the big monolith into more distributed or more microservices architecture?
Okay, so I'm going to repeat it for the camera. The question is, how did we establish our bounded context? And the thing that we did is we basically set the team down at an offsite with a whiteboard, and we said, what are the biggest pieces of our system? What are the independent products that would provide value independently if they were not tied to the other system? And we came up with 3 really big ones. For us, we do online video-based technical training. So we've got our learners who view our videos, and then we've got our authors that create our videos, and then we've got enterprises that they want to decide what people are watching. So they have plan managers that manage the plans of users, right? We kind of broke into big pieces first to get practice with it, to split things apart, because we weren't sure that we would be able to divide into a bunch of small pieces really quickly and get those boundaries right. And even now, we're dividing things small, and then sometimes we're like, we should put those 2 things back together. Those really do not belong apart from each other. They're sharing too much, right? Does anybody have another question? Let's start in the back.
So, talking about putting things together, how did you maintain your data quality and consistency now that you're talking about a distributed system? Does everything still have a relational association to it?
So a lot of our data right now is being moved out of document databases into Cassandra. And we actually have a data team that listens to almost all of our events, and they create reporting off of the end. So they're kind of our second check, our audit of, are we losing anything in the system? Plus, we have a lot of developers that they're test infected. They do a lot of integration and acceptance and unit tests to verify each piece that they're doing to make sure that we don't lose any data as we're extracting things apart. Right? And as I mentioned, we have actually divided the system in such a way that there's a bunch of, in order to get a cohesive view of a user account or of a user, you have to look at multiple systems. All right, and then I had a question up here in the front. 1 minute.
With some of the acquisitions that Pluralsight's been doing, what are some of the integration pain points that you've had, and how does some of this, maybe the microservice technology, architectural style, help solve some of those?
So one of the things that happened is early on we were just doing acquisitions of content, right? Those are super easy, you just put the content in our system. Later we bought a company that had written their entire stack on PHP, and we realized that we were going to have to integrate identity, so we had a cohesive user account across both systems. And we couldn't just move the content because that content is very specialized to a specific audience. And we weren't prepared to serve that audience in the main product at that point. So we built up some of these blocks, like the identity block and some of the communication across data centers so that we could integrate those 2 pieces. And that's where a lot of those patterns came in. With our most recent acquisition, which was Code School, we actually integrated them ridiculously fast because we'd already built those pipelines and those patterns, and we said, subscribe to this message, publish this message, we'll add a link, and we'll be golden. And it took a very short amount of time. Do I have time for one more question? Okay. I have office hours on Thursday in the afternoon, so if you have more questions, feel free to track me down there.
Thank you.